All right, we're on our last set of notes for day 2. So day 2, block 4. So now we're going to combine some algebra with our parallel lines. So a little bit more practice with the definitions we talked about in the last video. So we're going to start with a bit of a warm-up here. Just the first 6 problems I want you to try on your own. It says, identify each pair of angles as corresponding. So you can label it C, alternate interior, AI, alternate exterior, AE, or none. Okay, so you can use the letters. Just label the first 6 angles as one of these 4 options, and then I'll go through them. Okay, here are my 6 answers. So number 1, they're corresponding, X and Y. Number 2, alternate exterior. Number 3, corresponding. Number 4 is technically none, but we know that can also be called same side interior. Those are supplementary angles. Number 5, alternate interior. And number 6, alternate exterior. So if you're having trouble with these, make sure you go back to the video, block 3 video, or ask a question. Let me know if you need help with them, need more practice, things like that. The next couple here, I wanted to do with you just because they get a little bit more complicated, and we'll just go through them. So we have angle X and angle Y. Something that might help is to kind of highlight the angles or the line segments, lines that are making up this scenario. So my 2 parallel lines in the transversal, I highlight in red. Remember, if you hold the shift key, you'll get a straight line. So that makes it a little bit easier to see that these guys are alternate interior angles. Number 8, again, it's kind of tricky because there's so much going on. Looks like this one and this one are the 2 I care about here. And here's my transversal. Okay, now when I focus on just those, this is on the outside of the parallel lines and opposite sides of the transversal, so alternate exterior. The last couple, not too bad, so obviously these are my 2 parallel lines. This is the transversal I care about. This is technically none for this question, but we know that these are same side interior. And then the last one, here's my transversal. Looks like this line and this line are the ones I care about here. So inside, outside here, but the same side of the transversal, those are corresponding. Okay. All right, so let's use that knowledge to expand a little bit more. So we're going to find X and Y here. So now we have 2 variables. So that means we're going to be solving some systems, just like we did on the first day. So let's set up some equations based on what we know about these angles. So I need to find 2 equations that I can use to solve my system. So I know that 5x plus 2y, that should be the same as 2x plus 80 because those are vertical angles. Okay, so we're tying in everything, not just the transversals definitions. I'm going to solve this guy. I'm going to get x and y on the same side here. So I'll subtract 2x, so 3x plus 2y equals 80. So that's my first equation of my system. Now I need a second equation to go with it. So the other piece I know is that 2x plus 80 should be the same as 12y minus 100 because those are corresponding angles. So they're equal to each other. I'm going to get x and y on the same side and the constant by itself. So I will subtract 12y, so 2x minus 12y equals, I'm going to subtract 80 to the other side, so negative 180. Okay, so now I'm going to solve this system. So this is my second equation. So I'm going to put them together here. 3x plus 2y equals 80, and 2x minus 12y equals negative 180. So I can see that in order to solve this system, I'm going to need to do some multiplying because my goal here is to eliminate. That's what I like to do. So I notice that if I multiply this top equation by negative 6, then I'll get negative 18x negative, I should multiply it by positive 6. Get rid of that because I want it to be plus 12y equals 480. So now I can add these two equations. 2x plus 18x is 20x. The y's cancel out. This equals negative 180 plus 480, 300. We'll divide by 20. X equals 15. So I'm halfway done. Now I need to plug it back in to solve. So I can plug it into either equation from the beginning, it doesn't matter. So I'll do the first one. So 3 times 15 plus 2y equals 80. 3 times 15, 45, plus 2y equals 80. So now I have 2y equals 35 and y equals 17.5. Okay. I can do the same thing for example 2. So let's get started with it. I'll help you set up your equations and then you'll finish the problem on your own. So again, I need two equations. I'm going to draw a line here to separate this a little bit. So when I look at this, I notice I have these corresponding angles here. And I only have one variable. These guys should be equal to each other, so I can start with that. 12y plus 39 equals 87. Now this is actually easier because it's just a linear equation, so I can solve it right away. 12y equals 48, divide by 12, y equals 4. So now I just need a second equation that I can plug that into. So the other relationship I see here is this guy up the top, looks like a straight angle. 7x plus 18y plus 87 equals 180. So I can plug in my y value, plus 18 times 4 plus 87 to solve for x. 18 times 4 is 72. 7x plus 159 equals 180. 7x equals 21 after I subtract 159. X equals 3. I'm done. So actually I did the whole thing with you. So now I found x and y and I'm done. I didn't even have to really do a system for this problem. Okay. So our last set of examples together. These are called crook problems. You ever hear like the crook of your elbow or something like that? It's kind of a bend. So you'll see some parallel lines, but then instead of just like a regular transversal, weird crooked lines. So we're going to use some strategies, parallel lines, all the things we've talked about with them. Vertical angles we've looked at today already, supplementary angles, and triangles if you can. The best piece of advice though is to draw in more parallel lines. Okay, and you want to draw them in the crooks, so in the bend of the middle part. So let's do a couple together here. Line A is parallel to line B. Okay, so there's my symbol for parallel. And we want to find x. So I'm going to draw in another parallel line as best I can. It's not going to be perfect, but I'll use shift to make it straight-ish. Something like that. Now I have this third parallel line, so I can focus on this first transversal kind of on its own. So this angle right here has an alternate interior down there, that little guy. So he's also 70. Okay, so then I'm going to look at what other information I know. Well, 45, this transversal, this 45-degree angle is corresponding with this one. So here is also a 45-degree angle, right? They're different transversals, okay? So I know angle X was originally that entire crook, the whole bend. So to find X, I'm going to add 70 plus 45 to get 115 degrees. Okay, so drawing in another parallel line usually helps. Let's look at example 2. So I'm going to draw in Couple more parallel lines. They're not perfect, just do the best you can. Okay, all of these are parallel. My goal is to find angle C. So again, I have this first transversal. I have to kind of ignore the 86 for a moment. Just this little part here is alternate interior, so that's also 30. Okay, so now the 86 is helpful because I know 30 plus this missing angle should equal 86, so I can find it by subtracting 86 minus 30 to get 56 for this little guy right there. And then I have the transversal, another alternate interior, so this one's 56 as well. And lastly, I have my transversal down there. So alternate interior here and here. This one's 22. Angle C, it's kind of hard to see down there. Angle C would be 56 plus 22 for 76 degrees. So it's kind of like a little puzzle. You have to do like one piece at a time to put them together, and then you can find whatever measure you're looking for.